This is a graphic of the world's most powerful supercomputers at this very moment. These are ranked in a unit called flops. This unit basically tells you how many calculations or operations these computers can perform in 1 second. At first glance, these devices might seem like normal computers, just faster and way bigger. But they actually have a very crucial importance in this world. They generate some of the most important data we need, including the calculation of the power of nuclear warheads, generating cures, but more importantly, calculating the weather forecast. And they do so much more, but more on that a bit later. Supercomputers were first introduced back in the 60s, with the first one being the CDC, developed by a literal genius, Seymour Cray. Those early ones were mostly made for government purposes. It was during the Cold War, so cryptology was a big thing. Supercomputers were then very important when trying to decode messages by identifying patterns in pieces of text, for example. Another reason why governments needed that kind of computational power, in 1992, the US officially stopped nuclear explosive testing, meaning they had to stop exploding nukes to understand how powerful they really were. They were still producing more and more nuclear weapons though, so they needed a way to accurately simulate and model the amount of power and the potential amount of damage those warheads could actually produce. That process is very demanding as it needs very complex mathematical models to reproduce a nuclear explosion, and it also needs demanding simulations. Supercomputers are perfect for that sort of work, and many of them, like Cielo, were specifically designed for this goal. And back in 2019, Cray Supercomputing, one of Seymour Cray's companies, received a contract from the US Department of Energy to build El Capitan, a supercomputer that will, among other things, calculate the power of the nuclear warheads of the country. And more interestingly, it's expected to be the world's most powerful supercomputer in 2023 when it actually launches. So if we get back to the graphic, the first important thing to notice is that this portion right here represents the top 5 most powerful supercomputers in the world. So in 5th place there's Perlmutter from the US, then comes Sunwave from China, and then there's Sierra again from the US, which is very close to the previous one in terms of speed, with only 276 teraflops separating the two. Then in 2nd place from the US again comes IBM's Summit. It was the world's most powerful supercomputers from 2018 to 2020. And finally from Japan comes Fugaku, which is just on another level. This one has more power than the 4 previous one combined at 537,212 teraflops. That is just a tremendously powerful machine. This type of power can be hard to envision. So to really understand what those teraflops really mean, the second part of the graph here shows you a few consumer products. For example, there's the Nvidia RTX Titan. It's a powerful graphics card, but it's only at 130 teraflops. And even more recognizable is the Xbox Series X, and this one is way lower at only 12 teraflops. It's nearly 45,000 times less powerful than Fugaku. So now you at least understand the superiority of these machines, but said like that, it almost has no meaning. Those are just numbers. So what really creates the gap between your average computer and these monsters, except the teraflops? Obviously, there's the tremendous size of these machines. They can take entire floors of a building. But there's more to it. First, they're using the fastest high-performance stack available at the time, meaning the best CPUs. Then, to maximize the performance, supercomputers are covered in cryogenic fluid, essentially extremely cold liquid to keep any heat out of the system. And lastly, supercomputers can work with multiple lists of numbers in a process called vector processing, making them even faster. Now, to showcase the usefulness of these billion-dollar machines, let's take the weather for example. At this very moment, there are thousands and thousands of sensors, balloons, satellite, radars, weather boards, capturing weather data all around the world. But the challenge is turning that data into the forecast. Governments have supercomputers that uses NWP, short for numerical weather predictions. They're essentially mathematical models that are representative of the way that weather works. To make those sort of predictions, you need beefy computers, as they're essentially simulating the weather using all the data I listed. And simulations are extremely resource intensive, especially at that scale. So assuming you have enough power, you can predict pretty much anything from hurricanes to tornadoes and even climate change. Other fields of supercomputing are medicine, which is mostly developing new drugs and understanding how diseases affect us. The evolution of space and trying to understand its origin, decoding the way it works, and what the future has for it. So the answer to why we keep building these billion-dollar machines is actually very simple. We use them to elevate our knowledge of the world and to create new ways to make our life easier and to save a tremendous amount of time. But that's just my opinion. Do you think they're worth the billions of dollars the governments put into them? Tell me about it in the comments, and don't forget to subscribe.